Okay, so we are going to do some basic algebra right now. Essentially, I'm going to play with exponents. So we always want to remember, please excuse my dear Aunt Sally, which actually is not a perfectly up and down acronym. Actually, the P's by itself, then the E's by itself, then MD on the same line, then AS on the same line. So it's sort of a triangle, Christmas tree or something. So the parenthesis is first, then the exponent's next, and then multiplication and division can be in any order, right? Because those are the same on the same level. And then addition and subtraction in any order. Generally, left to right is preferred, even if they're, in these on the same lines. But let's try a few. So let's do negative 2 cubed and negative 2 cubed. So 2 cubed, you might want to expand it until you get really, really good where you never make a mistake. And so expanding it to 2 times 2 times 2, because that's essentially what it is, right? It's just 2 cubed. So that's it. That's 8. Right? So then you don't make the mistake of doing 2 times 3, which obviously can happen if you don't have a lot of experience with that, where you just look at it and you just know immediately. So remember, guys, one of the thesis statements of these videos is for you guys to just play with numbers. Please just play with them a lot. Okay, so here, PEMDAS, right? So 2 cubed, and then essentially what this is this is essentially negative 1 times 2 cubed. Well, obviously, since parenthesis is first and exponent is next, right? Well, this is a parenthesis and it's an exponent, right? So we know that's going to be first. So we're going to evaluate that, and then we're going to do multiplication and division. So then we're going to multiply by negative 1. So now you've got essentially what is negative 1 times 8, which is negative 8. Very nice. It's a little different. So we're going to evaluate 2 cubed, get an answer, and then multiply by negative 1. So now, same as this, right? Same as this, exact same thing. So it's 2 cubed, which is 8. Right? It's 8. And then make it negative. So it's either negative 8 or negative 1 times 8, which is the same as negative 8. So those two are exactly the same. So the other thing would be to play with 2 cubed, right? So let's say you did 2 cubed plus 2 squared. Then let's see if you did 2 cubed times 2 squared. Let's sort of work the numbers out and see if we can spot any patterns. So you want to always look for patterns and when you're exploring math and numbers, etc. So 2 cubed is 8. 2 squared is 4. So you've got 2 to the 12th, or rather 12th, rather. Now 12, is that 2 to the 5th? No, that's not. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. So we're going to skip 12. So it really doesn't, we don't really discover anything really fascinating when we're adding these. Let's see if we see anything interesting when we're multiplying these. 2 cubed times 2 squared. That's 8. And we got times 4, which equals 32. Now, should we know this pretty easily? I would say yes. I would say if I was going to add an addendum to previous videos where I mentioned, memorize your times tables to 10 or 12 or 15, memorize your cubes to 6 or 8 or 10. Well, here I would say at least the first 2 or 3, numbers 1, 2, and 3, you should try to memorize you know, you're like going beyond just 2 to the first, 2 squared, 2 cubed. You want to study, like, you know, 2 to the 7th. So, you know, 2 to the first is 2, obviously, and then 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. So these are helpful because they show up a lot. They're just gonna be in a lot of, you know, math assignments, textbooks, etc. Like, you know, because you're gonna be multiplying, you know, these fractions and whatnot. So, and exponents and whatnot. So 2 cubed is 8, 2 squared is 4, etc. So just trying to remember these like the back of your hand would be very, very helpful. You know, even 2 to the 6th being 64, there's a 6 in 64, just stuff like that. Not required, but it definitely helps. And you don't have to do all of them, like, you know, 5 or 6 or 7. I mean, but I mean, the first few for sure, 1, 2, and 3 would be really, really helpful. Because you're still in single and double digit land. So, but yeah, so 32 is 2 to the 5th. So hopefully you immediately go, okay, that's going to be 2 to the 5th. So what's the pattern? Well, we just learned the rule from the example. And that's the other thing that I like to do is, even if I don't know a rule, I might learn a rule, but then you want to like go back and pick examples and then study the examples, you know, see the answer. You know, maybe you see the answer in an example on a website or in your textbook in the back of the book. Maybe you see an example on here on YouTube, you know, but you see an example and then use that example, and really, if you don't understand the concept, take that example and learn the rule or the rules or the parameters of that concept and that sort of process, that theorem or postulate, etc. So what did we just learn? Well, here it is. So what's probably the case, even if you didn't know the rule, is you could spot a pattern. You say, oh, this is 2 to the 5th. This is probably, if the bases are the same, and you're multiplying 2 cubed times 2 squared, it's probably adding the exponents. And what I would say is you can fit a big plus sign in here. And, you know, so we can test that again. So you can say, okay, well, let me just test it one more time. So let's say you did 3 times 3 to the 4th. Right? So 3 to the 1st, or just 3, times 3 to the 4th. That's going to be 3 plus, what's 3 to the 4th? 81. So if you try to memorize those, right, 3 to the 1st is 3, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81. Very helpful. That shows up a lot. 3 to the 4th, 81. So it's 84. Well, is that 3 to the 5th? Let's try it. Oh, I'm sorry. What am I thinking? 81 times 3. 243. But of course, and this is something that you'll catch, especially if you're doing a little bit of extra work. You know, that's the challenge too, is I always, you know, I think it's generally helpful if you can just go a little bit above and beyond, you know, a little bit above and beyond what's being assigned, you know, in your classes and whatnot. Just say, you know what, I want to learn this stuff. I want to explore this stuff. I want to memorize these numbers. 3 cubed is 27. 3 to the 4th is 81. If you can just memorize these, it's going to save a whole lot of heartache down the road. I mean, it can't really hurt. You know, it doesn't take that much time to really get this stuff down pat. And, you know, even 3 to the 5th, it's still only, you know, 3 digits. It's reasonable. You could probably remember it. You know, even if you stop there, I mean, just knowing these like the back of your hand, super helpful. So, okay. So 243. Let's see. Does 3 to the 5th equal 243? Well, let's try it out. So it's going to be 3 times 3 times 3 times 3 times 3. So it's 3. So it's 3, 9, 27, 81, 243. It is 243, right? And what do you do with these? You're going to add them. All right, so we just learned that rule with a few fairly simple examples, right? Positive integers, positive integer exponents, and we learned that if the base is the same, and try to create a memory hook, right? So I usually think, well, if I've got 3/5 squared, what is that going to be? Well, it's going to be 3 to the fifths, rather. 3 to the fifths times 3 to the fifths, right? Because you're squaring that whole thing inside the parentheses. So you just, this times itself, which equals, and the actual rule is 3 to the 10th. So you can add up these. So if there's a big space, you add them up, right? 5 plus 5 is 10. But here, what is the obvious thing? Well, 5 and 2 equals 10. What's the computation? Add, subtract, multiply, or divide. It's going to be multiplied. So how I remember this is you can only fit a little dot in between these exponents when they're smashed together like this. So it's 3 to the 10th. So you can only fit a little dot. Whereas here, there's so much more room. You can actually fit a big plus sign there. And so it ends up being 3 to the 1 plus 4, which equals 3 to the 5th, which equals 243. So creating these memory hooks is really important. So as you learn new information, you want to figure out how to file this stuff away so that you can remember it on tests, quizzes, and just later on in life as needed.